In the first activity, we're going to introduce the sine law. We understand how to calculate lengths and angles in triangles if it's a right angle triangle using our primary trig ratios. But what if we don't have a right angle triangle? Before we can get started with the sine law, I want to make sure that everybody understands how to label your triangles. The angles, or the vertices, we represent them with capital letters. And the sides opposite these vertices we represent with a lowercase letter. So for this triangle, since this is angle A up here, across from it is going to be side A. Across from angle C is going to be side C, and across from angle B is going to be side B. And the sine law, when we're trying to determine the length of a side, is written this way: as a ratio of the length of side A over the sine of angle A, and that's going to equal the ratio of the length of side B over the sine of angle B, and the ratio of side C over the sine of angle C. When we're trying to determine the measure of an angle, we write the inverse. So sine of angle A over A is going to equal the ratio of the sine of angle B over side B is going to equal the sine of angle C over side C. In order to use the sine law, you must be given an angle and the length of the side that is opposite it, plus one other piece of information. If we don't have an angle and the opposite side, we can't use the sine law. So let's take a look at this example here. I'm going to label this with A, B, and C, which means that this is going to be side A, this is going to be side B, and this is going to be side C. Because we're given angle A and side A, we can use the sine law. Because I'm looking for the length of a side, I'm going to use the sine law in this form. So I'm going to start with side A over sine of angle A. Now I'm looking for side B, so I'm going to use side B over sine of angle B because I'm given angle B. Now I can plug in what I know. I have 18 over the sine of 83, and that's going to equal x over the sine of angle 49. I can cross multiply, moving sine of 49 up to the top of the left-hand side or into the numerator. I'm going to end up getting 18 times sine of 49 divided by sine of 83. And now I'm going to punch this in on my calculator to calculate x. If you need to, you can calculate sine of 49 and sine of 83 independently, but you need to remember to keep at least 4 decimal places. And I'm going to start by entering in 18 times, and now I want to figure out what the sine of 49 is, so I have to start with 49, and then in my trigonometry drop-down I'm going to select sine. I want to see what the answer is for the numerator, so I'm going to hit the equal button. Now I'm going to divide by sine of 83, and I start off by typing in the angle 83, and then on the trig drop-down select sine. Now hit equals, and I've calculated x to be 13.68679 and so on. I'm going to round that to 1 decimal place, so x is going to equal 13.7. Now let me show you how you can use the sine law to calculate an unknown angle. In this diagram here, I'm going to label it with A, B, and C. So this is going to be A, B, and C, and it really doesn't matter where you label A, B, and C. For this diagram, I'm given angle B and the side opposite, so I can use the sine law. I'm also given one other piece of information, and that's the side opposite the angle I'm looking for, angle C. So I'm going to use the sine law written this way: sine of angle B over B is going to equal sine of angle C, which is what I'm looking for, over side C. Substituting in what I know, I get sine of 32 over 12 is going to equal sine of C, which is represented by theta, over 20. Cross multiplying, I end up getting 20 times sine of 32 over 12 is going to equal sine theta. So let's calculate what sine theta is going to equal. I'm going to start by entering in 20 times. I'm going to enter 32 and find the sine of 32. That's what my numerator is going to equal. Now I'm going to divide by 12. And I get 0.8832. I'm going to keep that value on my calculator so I don't have to round. And now, to find out what theta is, all I have to do is use my trig drop down, second function, sine inverse, and now I know that angle theta is equal to 62.0 degrees. If I would have used the answer I got for sine of theta rounded to 4 decimal places, so 0.8832, and then tried to find the sine inverse of that, you'll see I would have got very close to the same answer. All right, that's how you can use the sine law. Good luck on your homework for today.